Hello! In this lesson, we're going to be talking about maps. So you can see on the screen here, there are several different kinds of maps. We have down here a map of a ski slope. We have a globe over here. We have a topographic map over here, which we'll talk about later. We have an interesting map over here, which shows the population of the United States. All of these little peaks here are showing how many people live in that area. You can kind of see from this map that a lot of people live in coastal areas in the United States. And we have several other maps here, a subway map, and we have this map of nicknames by state. So lots of different kinds of maps. Remember, for your homework assignments, every time you see a red slide, that means you're going to have to write something in your notes. Don't forget to look for the owl and describe where he is. And last but not least, give me a 2 or 3 sentence summary. If you want to do more, that's fine, but at least 2 or 3 sentences summarizing the main things that you learned in this lesson. You need to complete all of those parts in order to get full credit on your homework assignment. So, this is the Earth, and one of the things you can notice about the Earth is that it is round. You can see it in the picture in the bottom right very clearly. The picture in the bottom left is a very famous picture of the Earth taken from the moon. Showed a lot of people how small the Earth is in the vastness of space. So sometimes we need to make a model of the Earth. Models can help us very much in science. We can make models of atoms, we can make models of buildings, we can make models of lots of different things, and this is a good example of a model of the Earth right here, and this is a pretty good model of the Earth. It's basically the right shape. All of the continents and oceans are in the right places and look more or less what they look like on the real thing. And these are some other ones. These are some other models of the Earth. These are some maps here. You might be familiar with Google Maps these days. But back in my day, when I was a kid, we had paper maps. But this is kind of interesting. I want you to take a look at something here. Right here, this country here that I'm outlining, this is Greenland. And right here, as you know, is the United States. And I want you to look at how big these are compared to each other. On this map, it looks like Greenland is quite a bit bigger than the United States. But I want to show you something interesting. Right here, this is an actual picture of the Earth taken from space. One of the cool things about this is that you can see all the lights lit up in the United States here. And again, you can kind of see where people live in the United States and that they live sort of near the coast because there's more lights there. But what I really want to show you, if you remember up here, here's Greenland, right? And here's the United States. And again, Greenland looks quite a bit bigger than the United States. But if we look at this on the actual Earth, well, here's Greenland again, and here's the United States again. And clearly, on the actual picture, the United States is a lot bigger than Greenland. So what's going on here? Well, the actual picture, that must be correct, right? That's what the Earth really looks like. So why is this not right up here? Well, this has to do with a bit of a problem in creating maps, and that is, how do you get something that is round, the actual Earth, onto something that is flat, like a map? Well, when you do that, what happens is some things kind of get stretched out and distorted. So this idea of putting the actual Earth onto a map is what we call map projections. So these are 3 common examples of map projections here, and the idea is that we're taking the round globe and basically projecting it onto a flat surface, and sometimes we have to use a cylinder shape, like the one on the left. Sometimes we use a cone shape like the one in the middle, and sometimes we just project it onto a plane like the one on the right. And all of these have their pluses and minuses to them. Okay, so the first one is called a cylindrical projection, and this is really one of the most commonly used ones. The second one is called a conical projection, and last but not least, we have an azimuthal projection. It's kind of a hard word to say, azimuthal. So what do we need to know about map projections? Well, first of all, as we talked about, map projections cause distortions. Again, we can see the difference in size between Greenland and, in this case, South America, or we could look at the difference between Greenland and the United States, but we can see on this little globe right here that those sizes really are not correct. And basically, when we talk about it causing distortions, what we mean is that certain things get stretched out. And in the case of a cylindrical projection, things get stretched out more near the North and South Pole, and they don't get stretched out very much near the equator. People that make maps are called cartographers, and the process of map making is called cartography. And the way in which map makers make maps has really changed a lot over the years. You can see up here a compass. This object at the top right here is called a sextant, which was used to make maps thousands of years ago, especially maps of the sky, but it was also used to locate your position on Earth. But these days we use what's called remote sensing for the most part. I don't know if you've ever seen this before, but you may have, if you're lucky, you may have seen one of the Google Maps cars go by at one time. That's how they make the Google Maps images. They have a car that has a camera on it that takes all sorts of pictures and videos. We also use things like lasers, and we use things like satellites to get images and to map out the Earth. So now that we know how maps are made, how do we find where we are on a map? Well, in order to do that, we need to know about latitude and longitude. You may have learned about this a little bit before, but we're going to go through what you need to know about latitude and longitude so you can find where you are on the Earth. Latitude and longitude are basically going to form a grid on the Earth so that you have your up and down lines, that's your line of longitude, and your horizontal lines, and that's your line of latitude. And as long as you have those two lines and you can figure out where they intersect, then you can find any place you want on the Earth. So please fill these things in your notes as we go along. These are your lines of latitude. They're also known as parallels because, as you can see, they're parallel with each other. And on the right, we have our lines of longitude, which are also known as meridians. For our lines of latitude, the equator is the one that's in the middle, and that is 0 degrees latitude. So as we go up each line, we're going to be going up in degrees latitude north, or if we go down this way, we will be going up in degrees latitude south. So I want you to think about this for a second and think about things that you know about circles and degrees. So if we draw a line in the middle of a circle like this, and that's the North Pole up at the top, well, how many degrees is this angle right here? Well, I'm sure most of you guys know that that's 90 degrees, right? So because of that, the North Pole is 90 degrees north, and the South Pole is 90 degrees south. Over here in the longitude, we have basically the same idea, but for longitude, we have the prime meridian. So the prime meridian is 0 degrees longitude, just like the equator is 0 degrees latitude. And by the way, the prime meridian goes through a town called Greenwich, which is in England. That's basically where they decided to put it. For latitude, it has to do with the spin of the Earth and the North and South Pole and things like that. There's an actual geological reason why the equator is where it is, but for the prime meridian, people just kind of decided to put it there. Now, there is a slight difference between the equator and the prime meridian. The equator goes all the way around the Earth, but the prime meridian only goes from the North Pole to the South Pole. In other words, it only kind of goes halfway around the Earth. So if we spin around the Earth to the other side, we have the international date line. And as you know, again, thinking about circles and degrees, if you go halfway around a circle, that's 180 degrees. So because of that, the international date line, or the IDL, is 180 degrees longitude. It is on the opposite side of the Earth from the prime meridian, which is 0 degrees longitude. Okay, so we know how to get to a place on Earth using latitude and longitude. So let's say we wanted to do that to go hiking the Appalachian Trail that's out in Western Virginia. And so we find the latitude and longitude of that, and there it is out near Roanoke and Blacksburg. And here we zoom in a little bit, and there we are. And we see this picture here, and we can see that this is kind of mountainous here. And maybe because we're hiking this trail, we want to kind of know how big of a mountain this is and how hard of a hike this is going to be. Now, what I'm doing here is, as you can see, I'm kind of outlining the base of this mountain here. So we can go all the way around like this, and that's kind of a line at the bottom of the mountain. We could say that everywhere on that line is kind of the bottom of the mountain, or everywhere on that line is at the same elevation. Now, here is a picture of the same mountain, but looking at it from the side. So I could do something like this, and I could draw a line here, and again, kind of outline the base of the mountain. And up here, I have the top of the mountain. So everything on this line is at least somewhat kind of the same elevation up here. So there's our mountain. Now, we first looked at the mountain from the top, and now we're looking at the mountain from the side. And you may know that when you look at, say, your face, or you take a picture of somebody from the side, that's called the profile. So we call it the same thing in science. We call this the profile of a mountain. So this brings us to the idea of topographic maps. And topographic maps do exactly what I was just doing there. They kind of draw these lines that show us areas of equal elevation. They show the shape of the land, or what's called the topography. And you can see on these pictures to the right here the idea of what it looks like from the top and what it looks like from the side when we draw these lines around a mountain. So here are some basic things that we're going to need to know in class about topographic maps. First of all, contour lines. Contour lines show points of equal elevation. So each one of these lines over here is a contour line, each one of those lines, and it corresponds to a line here. The above picture is what we call a profile, and this bottom picture here would be our topographic map. So now, if you look at your contour lines here, you can see that at this line here, or what we would look at as being this line here, right? And we all see the bridge right here, and here is the same bridge on the topographic map. And this line goes right past it, and as you can see, this line is labeled 100. Well, you can kind of see it, except that I drew over it. And this line here is labeled 200, and that would be like this one here. And this line here is 300, and that would be this line here. So what that means is that if you are walking up this hill like this, every time you hit another one of these lines, you've gone from 100 feet above sea level to 200 feet above sea level to 300 feet above sea level, and so on. So the idea here is that every time you go past one of these lines, you're moving up 100 feet in elevation. And this is what we call the contour interval. The contour interval is the difference in elevation from one line to the next. The index contour. These are lines that are going to be marked with elevation. Now in the last one we saw, that was a pretty simple map, but sometimes these maps get really complicated. And you can imagine on one like you see here that if we labeled every single one of these lines, it might get a little bit confusing and it might be a little messy and hard to read. So sometimes what they do is they will just mark off certain ones, like this one here and this one here, and you can see that those lines are also darkened to kind of help you out a little bit. That one there and that one there. Now, just like before, we should be able to count 1 line, 2 lines, 3 lines, 4 lines, and do a little bit of math and figure out what the change in elevation is from one line to a next, or our contour interval. It's just in this case that they don't mark every single one, and the ones that they do mark are called index contours. Another thing that we need to know is, if we look at this profile right here, and we see that this side of the mountain is very steep, and this side of the mountain over here is not very steep. And then we look at the corresponding topographic map. So this is the right side of the mountain, and here is the left side of the mountain. What do you notice about the contour lines? Well, we see that on the steep side, they're spaced very close together, and on the not so steep side, they're spaced much further apart. So that can tell us a lot about how steep a slope is, and that can be important, especially if we're doing something like hiking the Appalachian Trail or something like that. We want to know how steep these slopes are. So on this side, we have close together, closely spaced lines, and that indicates a steeper slope. And on this side, we have farther apart lines, and that indicates a gentler slope, not so steep. Last but not least, we see here we have a stream running down this mountain under the bridge, steep stream running down the mountain under the bridge. And what you see is a little feature that will help you to notice where a stream is. And that is that these contour lines make kind of like a little upside down V shape, right? There and right there. So the little upside down V shape indicates a stream, and you can also tell which way the stream is flowing. Now, there's kind of an obvious way to do this because water flows downhill, right? So it's obviously going to be flowing from the top of the hill down towards the bottom, but we can also see that the little point of the V points to the top of the stream. So those are all helpful things to remember about topographic maps. Okay, so those are the basics of what you need to know about map making. Cartography, that's what we call map making. For the most part, it uses things that we call remote sensing, which would be things like lasers and the Google cars and satellites and things like that. Map projections, this is how we get a round Earth onto a flat map. We need to know these 3 different kinds, with cylindrical being the one that is most often used. We need to remember that no matter what, all map projections cause distortions because there's no way of getting around the fact that we're trying to put a round Earth onto a flat map. We need to know about latitude and longitude. You'll need to know how to locate things, but we'll do some stuff on that in class. Some people like to remember that latitude is flatitude. I like that. You need to know about the equator, 0 degrees latitude, prime meridian, 0 degrees longitude, international dateline is 180 degrees longitude, and the North and South Pole are 90 degrees north and south latitude. You need to know about topographic maps. Topographic maps show the shape of the land, and know about your contour lines. Index contours, contour interval, and the spacing and shaping of the lines and what that tells us about the map. Don't forget to tell me where the owl is. Don't forget to write your summary, and I will see you next time.